Hello and welcome. I've got a good one for you today. So this last weekend, as you may know, was the first round of the 2022 season of the Financial Modeling World Cup, where I got a lot of my problems from. And it featured a very interesting problem, which I'm going to be looking at today, called More Fun in Fun City, which was quite tricky. Well, the whole thing wasn't too bad, but there was a bonus question at the end for 200 of the 500 or so points for the whole question, which the organizer said, I don't think they've ever given more than 100 points for a single question before, so pretty good signposting that this was going to be very, very hard. I didn't get it out. I don't think anybody got it out on the day, although I got kind of close. But obviously, as ever, I've had some time to think about it since, and now I'm going to show you how I would have got it out with the benefit of hindsight. So let's jump on in. Quick explanation of the problem. We've got this map, which you might be familiar with if you've seen the one I did on traffic, circular references, because it's a similar map to what was used in that. But this time we're not interested in the roads, we're interested in the buildings. And so basically each of these rectangles bordered by the roads is one district in the city, and as you can see if you zoom out, the city has many districts. We'll come to counting them in a little bit. And then within each district there are various different kinds of buildings. So we've got these residential buildings, we've got these which are factories, we've got these which are schools, these which are hospitals, parks, lakes, and then right in the middle in A31 I think it is, yeah, we've got this one town hall which is the center of the town. And then the other interesting thing I'll come back to in a minute is we've got the hands are like open land available for development. And so the idea is basically you're interested in the value of houses in this city, and the value of houses is a function of two things. One, how far away they are from the city center as defined by the town hall, and two, what amenities are available within the district. So in other words, there's a premium for having a school in the district, so that's a hospital, a school in the district, a hospital in the district, for having different numbers of parks, for having different numbers of lakes, and there's also a penalty for having factories. And so basically you put all that together, you can figure out the value of any given house in the city. And so the really tricky part is basically the optimization that comes at the end of this. So you can value every individual house in the city, you can sum up the value of all the houses in the city. The brief is that you're the mayor or the government or whatever, and you're interested in maximizing the value of houses in the city in total, because that's what your tax revenue is based on or something like that. And to do that you have all these community development slots, which are all these hand icons, and you can build new buildings on any of these in such a way as to try to maximize value. So in some cases you might just want to build new houses because there's more houses means more value. In other cases, if there's a bunch of houses, but let's say, like this district doesn't have a school or a hospital, then you might do more to increase the value by building a school or a hospital, or by building more parks or more lakes or so on. And so the challenge is to figure out the highest value that you can get the whole city to by adding new buildings. So let's dive into the details a little bit more. So yeah, I've kind of talked through the different icons. So in terms of the numbers, so base value of any house is $1 million. You lose 1% of the value for each block of distance from the town hall, and I'll just spend a minute on that because the way they define distance is a little bit weird. So it's not just vertical and horizontal. You can take diagonal steps as well. So for example, everything in this 3x3 box is within 1 step of the town hall, and then everything within this 5x5 box is within 2 steps of the town hall. And so if you kind of think about it for a few minutes, if you've got, let's say, a point up here, the distance is basically whichever is larger of the vertical or the horizontal distance, because whichever one is smaller you can cover that by doing diagonal steps toward the one that's further away and then step up to there. And the one other thing which always throws me a little bit, but that's kind of just the convention they pick, is you always include the starting and the ending block. So in other words, this one that's right next to the town hall, you should think of as being 2 blocks away from the town hall. You count the block you start on and the block you end on. So everything here except the town hall itself is 2 blocks away, then everything in the outer ring of this square is 3 blocks away, and so on. So for every block as defined that way that you are away from the town center, you lose 1% of your value, and then everything else is based on what's in the district, meaning in this little block that your house is in. If there's a school there, you gain 10% of value. If there's none, you lose 15%. If there's a hospital, you gain 5. No hospital, you lose 10. For every factory, you lose 10%. And then for the first park you gain 5%, subsequent parks add 2% each, first lake 7%, subsequent lakes 2% each. And the important thing is that for each type of building you add up the effects and then you multiply the different types together. So for example, if there are 4 parks, you get 5% from the first one, and then you get 2% times 3 from the other 3, so you get a total of an 11% uplift from parks. So in other words, your parks multiple will then be 1 plus those 2, which is 111%, and then you'll multiply that by your lake multiple, by your factory multiple, and so on. That becomes pretty important later when you think about, are you ever going to want to have 10 lakes and 5 parks and so on. So that's kind of enough by way of introduction. Let's dive on into the actual sort of meat of the problem. The first thing I'm going to do is just name this map range. I'll just call it map. And then the first constructive thing I want to do is I'm going to want to identify the districts. So first I'm just going to Alt-ES-W, pasting column widths in the same column doesn't change anything, it just lets me select a range that's the same size, and I'll just put an X in that. And there's some funky alignment because they were playing around with the alignment to have cars going up and down the roads. I'm just going to have everything go back to horizontal. And then I'm going to say, so let me talk about 2 ways to do this. The way I did it on the day is I copied the whole map and then pasted the format over here, and then I did, I made everything in X, and then I did a find and replace by format to replace all the whites with something else, and then kind of built formulas into those, which is a reasonably efficient way to do it. I like it better than anything where you manually tag or where you have to do lots of different formulas. But the standard I'd really like to get to is if somebody pasted a new map into this range, I'd like everything to update. So I'm going to show you a better way to do it, or at least a more flexible way to do it. And that's going to be, first I'm going to say if. So what I'm going to do is I'm going to match the cell. So this is the top left cell. So I'm going to let's just match this cell here against this list. If it's any of those 8 building unit icons, then it's part of a district. Otherwise it's part of a road, and I'm not interested. So 0 for an exact match. So what I'm interested in is there a match? So I'm going to wrap that in an if is error, and then I'm going to wrap that in turn in an if. So if that throws an error, then I'll just give it an X because I'm not in a district, so I'm not interested. Otherwise I am in a district, and then, well, let's just identify areas that are in districts and not. Okay, so now you can see it's identified the district here. The second thing I'm going to want to do is name the district. So in other words, to be able to use formulas to say, how many are in this district, I'm going to want a grid that has every cell in that district named the same way. Now the way, when I did it just putting formulas within the districts, I did that by looking to the left and looking up. As it happens, the way the map is placed, there's no empty column to the left, so I'm just going to modify that slightly by looking to the right and looking up. So basically I'm going to say, this cell, well, there's more district to the right, so take the value from there. No more to the right here, but there's one above, so take the value from there. And whenever I get to one that is the top right of a district, I'm using the fact that the districts are all rectangular, there's no funky shapes. Whenever I get to one that's the top right, then I'll take the name of that cell. So in this case, the top right cell of that district is E3, and so I'm going to name that district E3 based on the top right cell. So what does that look like? Let me just open this up one more line, and we'll do it here. So I'm going to say if the cell next to it is not blank, then take the value of the cell next to it. If the cell next to it is blank, that means I'm on the right hand edge of a district. Then I'm going to say if the cell above it is not blank, then take the value of the cell above it. And sorry, I shouldn't say not blank, I should say not X. Then take the value of the cell above it. Otherwise, otherwise I'm in the top right corner of a district, so I want to take the name of the column and the name of the so the name of the column, lock in the row, and then ampersand to combine it, and then come over here and lock in the column of that. Close my if, close my other if, press Control and Enter, and now you can see, this one is taking the value from here, this one is taking the value from the cell it's actually in, so, column E and row 3. So now I have all my districts named consistently. One quick thing to mention is, I'm implicitly assuming that there's no district right at the edge, otherwise I'd need to put a boundary of x's around the top and the right to make this work. But with this map, it's all roads around the edges, so I'm just not going to do that for now. So now I've got my districts. The next thing I need to do is get a list of my districts and figure out what's in all of them. So I'll quickly show you what I did on the day, and then I'm trying to be smarter about it. So what I did on the day, I did a unique formula across each row with true to return unique columns. So that lists all the districts that exist in that row, and then I just copy that down. I was obviously looking a little more carefully over here to see where I was, but if you do that once in each block, because the way the map is laid out, there's a road across between every layer of blocks. So you do that 1, 2, 3, 4, 5, 6, 7, 8 times, then you get 8 different sort of lists which between them have the list of all the districts, and then you can basically copy transpose those, copy value transpose, and then put them together in a list. So that worked, but like I said, I'd like to do it in a way that doesn't require so much manual intervention, and also there are ways that you could change the map that wouldn't work. Like if you divided this district in two, you'd need to be a little more careful about that, and so on. So quick aside here, if you want to do this in a dynamic way, you need a pretty powerful tool. So I'm going to actually write a lambda to do this, to do it in a dynamic way. So if you want to skip this and just go on and just imagine we've done the districts in that kind of semi-manual way I described, then I mark off the chapters along the timer in the video, so you can just skip over to the next chapter. But if you're interested, let me just show you quickly. So I'm just going to do very quick motivation for this. So let's say I've got 3 rows and 5 columns. Then I can do sequence 3, 5 to show me. Actually, let's do it 5 and 3, makes it a little neater, and we'll shrink everything a little bit. So here's my 5 by 3 area, and you can see the way that sequence works. It numbers them 1, 2, 3, 4, 5, 6, 7, 8, 9. So basically what I want to do with my lambda is unwind this so that I can list the 15 values in order. And the way I'm going to do that step by step is, first I'm going to work out the rows. So I'm going to want something that gives me 1s here, and 2s here, and 3s here, and 4s here, and 5s here, and then I'm going to work out the columns. So I want 1s all of here, 2s all of here, 3s all of here, and then I'm going to put that together into one formula that unwinds it. By the way, this formula exists out of the box in Google Sheets. It's called Flatten, and that's what I'm going to call my one as well. It's I don't know how widely it applies, but it's a pretty useful function when it does apply. You're welcome to steal my lambda, which I will put in the video description. So anyway, having said all that, to get the row number, the easiest thing is just to take this, divide it by the number of columns. And then you see I get 1, 2, 3, 4, 5 at the end, and then I get all these numbers, these non-integer numbers in between. And if I just round that up, round up to 0 decimal places, that could, whoops, sorry, I didn't mean to control enter there. I should have just hit enter because I've got dynamic array, so it's just one entry. And then once you've got that, to get the column index, you can just say equals this minus this times the number of columns, gets you almost there, and then you can see we just need to tweak. So we actually want to say this minus 1. So in other words, you subtract nothing from the first row, then you subtract the number of columns from the second row, you subtract 2 times the number of columns from the third row. So in general, you subtract the row number minus 1 times the total number of columns, and that leaves you with the column index. And then the nice thing about this is if I unravel this into one 15 thing long sequence, let's just take an example. So the 8th element in the grid this way is in the third row and the second column. So now if I unravel this, I should still find the same thing. So if I go to the 8th, it's in the third row and second column. So having done all that, I can basically now write a lambda. Now I have to emphasize this is not a lambda or a let tutorial. There are lots of good ones of those out there. I'm just going to write it, but if you're not familiar with this function, then by all means go and look at one of those tutorials. But basically lambda takes an argument and then does a thing with it. I'm going to use let to write the formula out in a neat way. So first I'm going to want to define the row count, and that's just going to be rows of RNG. Then I'm going to want to define the column count, and that's just going to be columns of RNG. And then let's come up here to write it. So then I want the row index, and that's going to be sequence row count times call count divided by call count, and then round up to 0 decimal places. So that's basically reproducing this formula over here. And then same thing for the column index, call_ind. We're going to want, so that's sequence again, row count times call count. So in other words, just a sequence, you know, from 1 to the number of things in the whole array. So sequence that minus row index times call count. Sorry, row index minus 1 times call count. So that's just reproducing this formula over here. And then now that I have the row index and the column index, what I want to return is just index range row index column index. Oops, not column count, column index. That closes the let, that closes the lambda. And now the way it is with lambdas, obviously you need to give them an argument. I'll put it in a name in a minute, but just so we can see if it's working, you can see that that kind of nicely unwinds 1 to 15. So that's good. So I'm going to drop that argument, I'm going to take the rest, put it in a named range, new, call it flatten. Unfortunately the line breaks that make it a little easier to read are lost in here, but you still have the spacing, so it sort of half works. Anyway, so that's flatten. That's my kind of quick motivation. So now, how do I get my unique list of districts? Let me just give this district range a name, districts, and then I'm going to say equals flatten districts, and that'll give me a very large 4,600 row thing, and then I'm going to take unique of that, and that gives me 1x because I've got all the x's where there's no districts, and then it gives me 60 districts, which is exactly what I want. And then just to tidy it up a little bit, I'm going to say, so you could say, you know, filter this where this is not equal to x. The disadvantage of that is that it's doing all the calculations twice, so I'll use let again. I'm going to say let dist list be this thing, and then I'll just say filter dist list where dist list is not equal to x. And that gives me a list of districts, so then district. And then what I'm interested in is counting the number of buildings by the different types. So that's just, I'm not interested in all of these, but it's easier to just do the whole lot. So I'm going to say countifs where map is this, and where districts is this. I'll lock in the column and put a hash on that because I've got an array formula there. So obviously town hall is kind of mostly empty. Let's just put in a total at the top so we can do some sense checking. Oh, and sorry, I'm going to collapse my formula bar now that I'm not writing a huge complicated lambda. So yeah, I've got one town hall just like you would expect. Copy this across, and I've got 775 residential units and 81 factories and 91 hospitals and 77 schools and so on, 120 plots open for development, which we'll come back to later. So now I'm interested in working out the valuation multiple. So I'm going to have the school adjustment, the hospital adjustment, the park adjustment, and the lake adjustment, and then an overall multiple. So let me just put this next to the assumptions tab so I can reference it quickly. So I'm going to say if the number of schools is greater than 0. You can just say if the number of schools, because 0 will be treated as false and 1 will be treated as true, but it's a little easier for a human to read if you say if greater than 0, I think. Then we gain 10%, otherwise we lose 15%. And then we're just going to say 1 plus that because we want to be able to multiply all these together. Let's just carry that formatting across. And then same thing for the hospital. I'm going to say if the hospital count is greater than 0, then I get that 5% premium. Otherwise, I get this 10% discount. And again, I'm going to say 1 plus that because I want to multiply these together in the end. Sorry, I have to do factories as well. So that's just going to be equals 1 plus the number of factories times that 10% penalty. And then parks, I'm going to say if, sorry, equals 1 plus again. If the number of parks is greater than 0, then I get 5% for the first park, and then plus the number of parks minus 1 times the amount I get for every other park. And I don't have to worry about the case where this is 0 and you're subtracting 2%, because this is only in a side of the if where the number of parks is positive. And I can say otherwise 0, or I could leave that second argument blank because that'll default to false, and 1 plus false is equal to 1 plus 0. But again, human readability, I'll put in the 0 just to be nice. And then basically the same formula for the lakes equals 1 plus if the number of lakes is greater than 0, then I get that first 7% plus the number of lakes, I4, minus 1 times the premium for each subsequent lake. Press enter, and so the overall multiple is just the product of those 5 submultiples. So now I've got my district valuation multiple, and the only thing I need to add to that is the distance from the city center. So let's do that one next. So again, I'll just Alt-ES-W to give me the range. I'll fill it all in with X's for a second so that I have a thing that I can quickly select, Control-Shift-Enter to highlight. Sorry, one quick thing I meant to mention earlier, actually. One question mark when you think about a problem like this, where you have a big grid input, is whether you want to kind of unwind it into just a list of all the intersections, or whether you want to do your workings in a series of subsequent grids. There are pros and cons for doing it each way. Honestly, the biggest single reason that I chose to keep working in grids for this piece is because the official solution that was put out doesn't unwind, so I'm just kind of showcasing the alternative approach. And similarly, when I do this distance formula, the way I did it on the day and the way they do it in the official solution, is you look at, like I said, we're interested in whichever is the larger of the vertical and horizontal distance. So you can do that by saying, the row that this thing is in minus the row that this thing is in, and take the absolute value of that, and then the same thing for the column this thing is in minus the column this thing is in, and take the absolute value. But just because that's already out there, I'm going to showcase a different approach using columns and rows. So I'm going to say first I'm going to say equals if no, actually no, I can calculate the distance for anything, whether it's a residential unit or not. So let me just say max. So rows. So I'm interested in how many rows are there from A1, which is just that top left cell, to the town hall, which we said is AA31. And I'm putting $, on the AA, $, on the 31. And the nice thing about rows is rows includes the starting and the ending rows, so I don't even need to do an adjustment here. And then I want columns of the same thing. So from A1 down to AA31, and the A1 moves, so for each different one here it'll be the distance from that cell to the town hall in rows and columns. Press Control Enter, just change the alignment to be all left to right. And so let's just see if we zoom in on where the town hall is. You can see we kind of get basically what we're expecting. So we get a 1 surrounded by a ring of 2s, surrounded by a ring of 3s, and so on out, 4, 5, 6, 7, 8, 9. So that is behaving the way we want to do. So now I'll just call that dist to dh. And then finally, we're ready to calculate valuation. And so for this one, I'm going to say equals if A1 equals, where's my little house icon, equals this, and you can either kind of lock that in, or you can just convert it to a value. Then what? Then I'm going to say it's $1 million base value times 1 plus the distance discount times the value of that first. Let's unwind this so I can see a little more. So times the distance of that one from the town hall times, and then I need to look up the district. And just to mix it up, because I keep saying I'll use indexed, I'll use VLOOKUP to stick it to the haters. So this time, just to mix it up, I'm going to use index. I'm going to index on the districts. I'm going to match the first cell here. So that's the first cell in my grid of districts against here. And what am I going to index on? I'm going to index on that overall multiple. And just quick aside, one of the reasons I like VLOOKUP is because you only need to reference the place you're looking up once, which is helpful if it's on a different tab. The way I get around that when I'm doing index and match is I put in a line break. That makes it easier to kind of click back to the bit in the formula that I'm interested in. So basically I pick up everything that's on the same tab, and then I go and do everything that's on the other tab, and then I'll remove that line break just to tidy it up. So I think that's it. That doesn't look happy. Oh, okay, fine. So false. So I can come over here and say otherwise 0. Fill that down and across. And now is this just, yeah, it's just tight on space. Okay, good. So let's just quickly format that. Number, no decimal places, 1000 separator, and then I'll just hide my zeros. And then let's widen that out. And that seems to be, causing all kinds of problems. So something is wrong here. So let's take a look back at this formula again. So that's locked in, that's locked in. A146 should be pointing to the first cell here, and it is. Oh, maybe the problem is that I didn't do that for the whole range. That's weird. Oh, okay, so I guess I left a couple of blank columns there. Maybe that's the issue. That's not the whole issue. Okay, so A146 times index districts match A74 against that. So let's just see what's throwing the ref error. So we've got a house, we've got $1 million, 25 units away, so you multiply by 75%, match E20 against the district list, gives me number 19. Okay, okay, sorry. So I see that this is, the lookup range is 50 to 63, but it's supposed to be right up to the top, so I should be looking up in from 4. Okay, so I see what happened. I scrolled down the district list. That left me seeing the page just from 50 up, and then I went across here and must have done something like that and left off all these cells up here. So whoops, but easy to fix. So let's come back over here and fix that. So it should have started in row 4, so let's just fix that to row 4. And that looks a little bit better. Okay, and so, what we should be able to see is, within a district, things that are, so you can kind of see it here, things that are equally far from the town hall are all equally valuable, and then each step away from the town hall reduces the value a little bit, and as you jump between districts, the values jump around. This one is super low, which probably means there's a lot of factories in that district, but let's just take a quick look. Zoom in a little. Oh yeah, so you've got 1, 2, 3, 4, 5, 6 factories, so that's knocking 60% of the value off, so it makes sense that that one would be much lower value than the districts around it. So that passes the quick sense check at least. So let's move on. So I think, so we've done the distance, we've done the valuation, so now I think we're ready to talk about the optimization. So the first thing I'm going to do is I'll put in a new tab for open lots, and I'm going to list them. And how am I going to do that? I'm going to say equals flatten if map equals, and I'll grab this little hand icon here. If map equals that, then I want the sort of coordinates of that point, and that's going to mean this and this. So the column name and the row name, otherwise nothing. That closes the if, that closes the flatten, and then I want to wrap that in a yeah, so I want to then filter that, because that obviously returns mostly blanks. So again, I'm just going to use a let, so I don't have to recalculate that to filter it. So open lots be that thing. Then I want to filter open lots where open lots is not blank, and then I get 120 open lots, which is the number that I was expecting based on this. So that's good. Now I'm going to copy and value paste that, because you could make kind of another copy of the map where you replace the hands, but because of the nature of the problem, it's faster to just do the optimization in the map as it is. So that's what I'm going to do. So I'm going to value paste that, and then I'm just going to manually replace the hands. So I'm going to go map. So hang on, sorry. Before I do that, let's just see. We've got so fill with, and let's just say that my starting hypothesis is let's fill everything with houses, because that's one thing we know will add value. I'll just freeze panes there, and I'll highlight that as my input, and then we'll come up with a cleverer way to fill that in a minute. But so for now we'll just say fill everything with houses, and let's just have over here the sum of valuation. So right now the total valuation is 650 million, and let's see what happens when I fill everything with houses. So I'm going to do find, sorry, I got to grab that little hand icon again. I'm going to do find that. I'm going to hit Alt-I to find all. Then I'm going to click down here in the results. You'll see there's, hang on, can you see that? There we go. You can see there's 120 cells found, which is what I want. Click down here, Control-A to select them all. Then I'm going to press Escape to get out of find, and then I'm going to start typing a formula. So I'm going to say VLOOKUP this column name, lock in the row, ampersand, whoops, this row name, lock in the column, in here. I'm even going to hard code the column number, because I promise to never insert any columns between these two. I know that's going to make some people mad. Anyway, Control Enter, and that fills that in all the 120 cells. And now you can see we've got a big jump in value. We've gone from 650 million to almost 750 million just by building 120 new houses. So that's a good start, but then the question obviously is, can we do any better than that? So now, before I kind of dive into trying to answer that, let me do a little bit of kind of quick background to try to think about what is a sensible way to approach this. Because right now we've got 120 open lots, and on each open lot it could potentially make sense to build any of 5 buildings. So we're not going to build a new open lot, obviously. There's only one town hall, and we'll never build a factory because that just reduces value. But we might want to build a residential unit, a hospital, a school, a park, or a lake. And so if you take that kind of most simplistically, that gives you 5 options. So 5 to the power of 120 is just a vast search space, no chance of working your way through that. By the way, just a quick aside, I did, when I was doing this on the day, I actually set this up for Solver, set this up with, variables from 1 to 5 here, and then, based on that, picking out the 5 sort of preferred building types. But for whatever reason, Solver was not able to handle that. I'm not kind of super up on the inner workings of Solver, so I don't really know why. Maybe somebody else does and can explain. But in any case, if you're looking at this thinking this seems like a thing Solver could do, as far as I can see, it's not a thing Solver can do. So we'll pass over that. The other thing is, obviously, in a competition like this where you get 200 marks for saying what is the exact, down to the dollar of the hundreds of millions of dollars, what is the exact highest number of value you can get the city to. If you use Solver, then you're never going to feel 100% sure that it has got to the single best thing. So how can we cut back this search space a little? First thing to think about is the only thing that depends on location for its value is the residential units, and there's a clear order there. So you'll always build the residential units on the side of the district closest to the town hall. So whatever number of residential units you think is optimal, you're going to build those closest to the town hall, and then everything else you can build wherever, because as long as it's in the district, that's the only impact it has on the value. So for the most part, we can just think about a set of buildings that we need to optimize now. We don't need to think about locations. The second thing is that we can always calculate the multiple impact that each new utility will have if you add it. So in other words, if there's no school, you take the school multiple from 85% to 110%. So in other words, the value will be multiplied by 1.29, 129%. If there's no hospital and you build a hospital, your value will be multiplied by 117%. And then, depending on the number of existing parks and lakes, it'll basically be, multiplied by 1 plus 2% divided by whatever your baseline is. So it'll be, a little under 2%, up to 2%. The second thing that's really important is that all of the utilities have diminishing returns. So, schools and hospitals are the extreme case. There's only one school that's going to add any value. There's only one hospital that's going to add any value, because there's only a premium for whether there exists a school or hospital or not. But then if you look at parks and lakes, they add 2% onto this thing, which varies with how many parks and lakes already exist. But the main thing is, the more parks and lakes there are, the higher the denominator is, and so the less they add. And so two things that means. One, you can work out which utility will be the most value adding among school, hospital, park, and lake, and you can basically work out what will be the what will we multiply the value of all the houses by with each one of those, and which is largest. And it's pretty easy to see with the existing values. If there's no school, the school is the clear choice. If there's a school but no hospital, the hospital is the clear choice. And after that, it's just whichever one of these has a lower value, with the small tiebreaker that if you have a district, I don't know if there are any, but if you have a district with no parks and no lakes, then the premium for the first lake is higher than the premium for the first park, 7% versus 5%. But after that, it's just whichever one has a lower denominator is the one you're going to want to build on. And so what you can do is basically say, here's my starting point where everything is houses, and then let's try replacing the lowest value house with the highest value utility. And if that increases the value of the district, then you keep that choice, and then you try replacing the next lowest value house, and so on up. And that's basically the whole idea. So so I'm going to calculate the next utility, as in the utility that I can add that will add the most value. And so that's going to say if the number of schools equals 0, then it's a school. If the number of hospitals equals 0, then it's a hospital. And then I'm going to say otherwise, so like I said, here it just depends on which one has the lower starting point, because that's the denominator, with the exception that if they're both 100%, you want to build a lake. So the way I'm going to do that is just give the tiebreaker to the lake. So I'm going to say if the lake multiple is less than or equal to the park multiple, then I want a lake. Otherwise, I want a park. And then I close all that up. And so that tells me for each district the best next utility to build. So then obviously for these, I want to figure out what district they're in, and then the next utility. So how do I figure out what district they're in? I'm going to say if district, so I'm going to say if this address is equal to the intersection that I'm interested in, so it's equal to those column names ampersand these row names, then give me the district, otherwise give me nothing, and then I'm just going to use concat to combine all those together. And so that tells me that V3 is in the district V3, and these two are in the district AH3, and so on. And then I'll look up the next utility based on that. So from here to here, for 16.0. And then, like I said, I want to replace the lowest value house, so I also need to figure out the distance of this space from the town hall. And that's going to be basically the same as this district formula, except that because I'm getting at numbers instead of text, I'm going to want a sum. So I'm going to say if this is the intersection, then I'm interested in distance to town hall, and if that isn't the case, then I get 0, and so that sums up. And so now what I'm going to do is sort. So I want to sort first by district, and in whatever order, and then by the distance from smallest to largest. So basically I want to replace the one at the bottom first. And so now this is roughly where I got to kind of on the day, except that I forgot to factor in the distance. So I was just thinking about optimizing the set of buildings, and so that's where I goofed. So here's AA3. So for example, if you just watch this overall value, the highest value thing I could add to AA3 is park. So if I copy value, paste that in, you can see I've gone from 748 million to 747 million. So in that case, I don't want to add a park. And because a park is higher value than anything else, that means that I don't want to add any other utility on this square. And because this is the lowest value residential unit, that means I don't want to change anything. So the highest value I can do for district AA3 is 3 houses, and then move on. So here's district AA45. I'll value paste in a school, and you can see this time my value has gone up from 748 to 751, and then it's this district map has now updated to say the next most useful thing is a hospital, and if I paste that in, that also adds value. So that's, in this case, I'd want to build a school and a hospital and no houses, and then similarly in 54 I can paste in a hospital, I can paste in a lake, and you can see when I add the hospital it adds value, when I add the lake it removes value. So I think at this point a reasonable person could say, well, let's just manually go through this and fill it in, but let's try and take it one step further. How could we make this a little bit more algorithmic? I'm not quite going to write VBA code, but you'll see the way I set it up, it would be very easy to then kind of VBA code it. So this is the next best utility. So then I'm just going to keep a record. You'll see why in a minute, because I'll be doing some copy value pasting of my incumbent. So my starting incumbent is all houses. Actually, let me just call that Gen 1. No, sorry, I'll keep it incumbent because then I can be more flexible. Then my candidate, and here what I'm going to want to say is my candidate is houses everywhere except the lowest value house, and there take the next best utility. So how are we going to do that? I'm going to say if this is not a house, just take that house icon. If it's not a house, then just keep it the same. Otherwise, if, oh, sorry, I need to add in row numbers here. So let me just park that for a second. Number, sequence, 120. Okay, so now I'm going to say, because I've sorted, in ascending order by distance, it's the last, it's the lowest value house if it's the house that's the highest row number in this district. So I'm going to say if this row number is equal to max ifs so the max of the row number where the district is this district, and where what it's filled with is a house. Oops. So if all that is true, then I'm on the lowest value house, and in that case I want to take the next best utility. Otherwise I want to take the incumbent, or otherwise I want to take the fill with. Yep. Y8, huh? Oh, sorry. So I pointed to that. I should have pointed to that. So now you can see for AA3 my candidate is 2 houses and then replace the last one. For A45 my candidate is 1 house and replace the last one. For this one my candidate is 3 houses, replace the last one, and so on down. So you can see for some of the bigger districts, like here AH28, lots of houses, I'm only changing the last thing. Then I need just a couple more things before I can go. So, well, let me just show you. District value, and then I'll do inc dist val and change. So the district value, I'm just going to do a lookup of the district name into this districts table. Sorry, no, I didn't add it in the districts table, so I'm going to do a sum ifs. Whoops, sum ifs. I'm going to sum the valuation where the district is this guy. Copy that down, format as a number, and then for my incumbent, I'm just going to copy value, paste that there. I'm going to say, what's the change? And so now, when I put my candidate in, we're going to see look, this district has lost value, this district has gained value, this district has gained value, and so on. So now the last step I'm going to do is I'm going to calculate a rollback. And I'm basically going to say if the district has lost value, so if that's, let's say if it hasn't added value, if it's less than or equal to 0, then go back to the incumbent, otherwise keep the candidate. And so now you can see, my original the candidate here has updated because now you've got something filled in here, and the next best thing is a lake, so I've got a new candidate. But my original candidate, which is now filled with, was 2 houses and a park. But now I'm saying actually I want to roll that back because 3 houses is more valuable. Sorry. Oops. So I'm pointing to the wrong thing. I should not be pointing to candidate because that's the one that updated live. I should be pointing to fill with. Okay, so now we're just going backwards. So for this one, right now I've got in a house and a school, and that added value, so I'm keeping that in my rollback. This one we added value, so I'm keeping the new hospital. This one added value. This one lost value, so I'm going back to all houses, and so on. So I copy that rollback, paste it in there, and now you see all the value losses have gone away, all the value gains have stayed. So now I've got a new incumbent, which is what I'm currently filled with. So I'm going to copy value paste that into my incumbent column. I'm going to copy value paste the district values into my incumbent district values. Look at the changes there. So now I just repeat the process. I take my candidate, put it into fill with, and you can see here it's trying a park again, because why not? It's still the next best thing. Here where we built a school before, now we're building a hospital, and that's added even more value. But in most cases we're going down. And then I apply my rollback. Whoops. Apply my rollback. And you can see all the negatives have zeroed out, all the positives have stayed. And so now I've got a new incumbent, so I copy that over here, and I copy my district values and put them into incumbent district values, and then I'll try again. I put in my candidate, paste it there, and now this time I'll just do a quick check to confirm, but if you look here, sorry, I don't want min, I want max. Is anything adding value? And the answer is no. The best anything is doing is standing still, and where it's standing still is the districts where there were no houses to replace. So here we've already replaced all the houses with high value utilities, so even my candidate doesn't have anywhere to put a lake, so it doesn't make any changes. So that strongly suggests that when I roll this back I'm done, and the way to double check that is to say, is everything in my latest fill with equal to the previous incumbent? If it is, then there's no way to add more value. It is. And so this number here, 792,003,712, is the highest value that I can get for the whole city. And so now just very quickly, I mentioned earlier that the standard I was aiming for was if we dropped a new map in here, could we just rerun this? So now we drop a new map in, all the districts recalculate. Based on that, my list of unique districts recalculates. I might need to expand or contract. These formulas are already linked to the number of districts because it's a dynamic array. These ones are not, although I could have written them that way. That might have been smarter. So I might need to expand that a little bit, but basically my district setup is good to go. The one bit that I was lazy about is I would need to then kind of select the map area and replace all the hands with the lookup formula for the open lots. I'd also need, this would then recalculate, and I'd need to copy value paste that over here. But aside from that, it's pretty darn automated. So all of this distance stuff, all of this valuation calcs would all just be automated. And then when it came to the optimization, as you can see, once you have the setup, it's a case of a half dozen copy value pastes to find the optimal value. And if you're that way inclined, or if you had a much more complicated map where you might need to go 10 generations or something to figure out the best case, then you could easily kind of VBA code all that copy value pasting. But since we only had to do it a couple of times, that did not seem worth it. So there you go. That's how in theory you could have got yourself 200 points. I think even with knowing everything in advance, that took me about 50 minutes. Could have gone a little bit faster if I wasn't chit-chatting and explaining so much, but that's what these videos are for. So the lesson I've learned from this is it was probably not wise to try to take this problem on. I would have been better off to just bank the time bonus for finishing early. I ended up like I said, I optimized for the set of buildings, but not for the locations, and I ended up, I think, like 0.03% off the perfect value, which is pretty darn close. But you know, in a world where it's all or nothing, you get 0 points for that. So I don't regret it, because I always try to you know, to shoot big. But maybe the next time there's a 200-point question, I will smile and wave and let it go on by. All right, thank you for watching, and I'll see you next time.